The next one will be the feature of the Huawei WLAN product. The objective: describe the basic feature of Huawei WLAN product. List key feature of Huawei WLAN product. So I will begin from the first one, the basic feature of Huawei WLAN product. So the AP, we can able to classify into two different types, the FAT and also the FIT. The Huawei AP can work as a FAT AP or the FIT AP and switch flexibly between the two working modes based on the network plan. When the wired network scale is small, the customer need to purchase only the AP product and set the AP to work as a FAT AP. So currently their network is not so big, so they just require few AP to have the coverage, okay, for the wireless access. So and they don't want to spend the extra money to purchase the controller. The Huawei give us this flexibility for us to swap the AP. So like I change the mode. FIT AP we can actually using some command to swap it back, become the FAT mode, become the independent AP. So as the network scale expand, 10 or 100 of the AP exists on the network. To simplify the network management, the customer are advised to purchase the AC to perform the centralized management on the AP and set the AP to work as a FIT AP. Switching a FIT AP to a FAT AP. So right now this connection topology will be very simple. They only have one switch put at the middle, and a lot of the PC is connected to the aggregation switch, and they just require one AP. So for this kind of network connection, it doesn't require the controller. When we want to swap the AP mode, so you can try to telnet or console to the AP, enter to the system view. So first, we're using a command AP-mode switch prepare. So we try to check. You see right now the AP is able to swap between the FIT and FAT. Okay, we try to using this command to verify first. Then the check whether the switch over preparation is complete. Okay, is it ready for change the AP mode? Okay, using the command AP mode switch check. So make sure the check is okay. Everything is already done. Then now we can change. AP mode mode switch FTP FAT AP. Okay, this one will be the system software for the AP. So right now they try to using the FTP way. Okay, you also need to point to the FTP IP address with your user ID and the password. Okay, if you want to using the FTP way to switch the AP. Because some AP by default they maybe not support the switch mode. So we already downloaded the latest system software from our PC. So and you want to put this file into your AP. So you can just connect your AP to the network and then try to telnet to your AP using the command from here. Okay, please make sure your laptop can support the FTP. Okay, run the FTP server on your laptop. Okay, this one will be your PC IP address. So once they already fully download, then they'll automatically restart. Then the next, check whether the switchover is successful. Now you can try to display version. So after we display a version, you can notice, okay, right now this is my AP model, AP4030DN. And yes, right now I am in the FAT model right now. Okay, this is a FAT. FAT AP networking mode. So we'll notice there's only one AP without any controller here. Okay, they actually for this kind of networking we call as an inline mode. Using the one SSID Huawei -1 with the service VLAN 101. Data planning. The DHCP server. AP will function as the DHCP server for SDA. IP pool for the SDA is using VLAN 101 and the range is 10 10.1.101.2 and end with the 254. Okay, the country code, CN, the SSID. So what is the name of the SSID? Okay, right now it's using Huawei WLAN. Security profile, the name, security-1, WEP, open system authentication, and no encryption. So it's just free for connect. VIP, name is Huawei-1, service VLAN is 101, SSID profile will be Huawei-1, security, I will using security-1. To set the AP become the DHCP server. Okay, right now they show you the way is with the CLI command line. So you have to enter to the system view, enable the DHCP, enable the VLAN, go to the interface VLAN 101, assign the IP address 10.1.101.1 space 24. So this is my IP address for my AP. And DHCP select interface. So this interface will be over the IP address for all the users who connected to this VLAN. For the country code, on the system view, type WLAN. And the next one, change your country code, okay, according which country that you belong to. Okay, now we can configure on security profile on the WLAN view. Okay, the WLAN view, you put the command security-profile name security-1. Okay, can be any name that you want. Then quit. Again, we create the SSID. SSID profile name Huawei-1. So on this SSID profile, you have to do some configuration. Give the name for your SSID. Alright, put the command SSID space the name. And then choose yes. Then the next one, configure the VAP. So to configure the VAP, you have to return back to your WLAN view. So VIP-profile name Huawei-1. Okay, now I already entering to the VAP profile. So I'm going to buy just now the SSID profile. Okay, this is the profile I created just now. Security profile, security-1, and also the service VLAN. So for those who connected to my SSID here, I will going to assign the VLAN ID 101. Okay, then quit. So by VIP profile on RF port and configure a default route to an upstream device. Because right now our API is deployed at the access layer. So it's on the access layer. So for all the access layer device, it's required to have the default route point to the uplink in order to route to the internet. Okay, so you have to add the static route on your AP. So this is the way for us to add the static route. Go to the interface, WLAN radio 000. Okay, now we need to do the binding first. So this radio 000, I'm going to bind VIP profile Huawei 1 and WLAN number 1, my first WLAN. So this is what I configured just now, the Huawei 1. Okay, this is the VIP profile. So right now I'm going to bind this one into my radio interface. Okay, this is my interface. Okay, once ready done, you can go to the IP, the system view again, system view, and then put IP route static 0.0.0.0 space 0 means anything. This is the default route and your gateway. AP management, automatic discover of AC. An AP can exchange the information with available AC to establish a connection with an AC. So when it started, the AP will first going to check, does the AP have the AC IP address configured? Mean, did we actually configure the static AC IP address on our AP? If yes, it will automatically set up the connection where the IP address that we configure. Okay, they'll automatically send the discovery based on the IP address that we assign. Okay, and then file the AC and establish the cat web. So this is a static way configure. If you never configure any AC IP address on our AP, so now the AP we're going to start send the dynamic discovery. Okay, it will send the broadcast, or maybe if we enable the option 43 on the DHCP server, yeah, and it will based on the option 43 and fire the AC. So when AP successfully associate with the controller, then they will form the cat web tunnel and end the connection. AC access control. After an AP is powered on, and AC checks some item to determine whether to allow the AP to go online or not. Okay, so just now the setting, right, is based on the AP only. So how the AP going to find the controller and establish the cat web. And now this one is the process on the controller. So now the AP found the AC. Now the AC have to do some checking. Okay, right now the AP try to connect, associate with me. Is the AP in the blacklist? If this AP is already added to the blacklist, so that means I will not allow this AP connect to my controller, so it will reject the access. So the AP will always fail to form the connection with your controller. If you never configure any blacklist, you go down here. Is the AP in the pre-configured list? So did we configure anything for this AP? Like, did we do any authentication, or do we do any registration on the controller? If yes, then the AP can straight away go online. Okay, because this is the authorized AP. If we never do any registration on the controller, so we're going to check, does the AP need to be authentication? So if you still remember, the Huawei controller can do 3 different types of the authentication. Default is a MAC authentication. Then the second is a serial number authentication. And the last is no authentication. They have 3 types. So if the Huawei AC controller never configure the authentication, so that means any AP can able to reach my controller, they automatically form the connection. See, now the AP can go online. So if yes, the AP required to perform the authentication, then you're going to check. Okay, first, are you have the MAC address or the serial number is already configured? Yes, then I'm going to check. Right now the AP in the whitelist. If this AP is inside the whitelist, I will allow this AP to associate with my controller. If no, then we have to do this one manually. So the administrator have to add the AP again to the AC. Okay, remember how to add the MAC address or the serial number. Okay, once everything is already done, then they'll go online. Data forwarding mode. The data forwarding mode will be very important. So sometimes when we deploy the network and we don't understanding what is the architecture or maybe the network design on the layer 2 or the layer 3, it's very hard for you to make the decision to choosing the forwarding mode. So right here they're showing the forwarding mode. They have 2 different types, the direct forwarding or the cat web forwarding. So what we need to know here is, for all the wireless packet, it's not the wireless packet, it's the protocol, like the frame using by the AP and the controller. All this kind of information have to pass through the cat web tunnel. Okay, maybe I try to draw another example. So, okay, I'm going to put this one is my AP. Okay, so I don't care, this one is either layer 2 network or layer 3. And right here I have one controller. I put AC. Okay, connected. And I also have one gateway right here. Okay, before you can go to the internet. Okay, so this one is the WAN. Okay, go to the internet. So right here I have one user. Okay, I want to go online using the wireless. So if I go into using the direct forwarding, okay, let me draw the tunnel first. After the AP associate with the controller, okay, after associate, so they'll form the carrier tunnel. So this is a carrier tunnel. AP and controller must always using the carrier tunnel to exchange the information. Okay, this one is happening in between the AC and the AP. They have no other option. Now, for the user frame we call as a data frame. The data frame, we have two options, depend which mode that you're going to select. If right now you select the mode is called direct forwarding. The direct forwarding, the user can send the frame to the AP, and the AP can direct forward your frame to the gateway and go online. So this is called direct forwarding. Just take note. And the next one, if right now I select the carrier tunnel forwarding, so same, the user data will first deliver to the AP. But because right now I'm doing the tunnel mode, so the tunnel packet have to entering to the tunnel first, and then go back to the controller. So then the controller will be based on the routing table and forward your data to the gateway. So they have two different configurations. So just take note. You have to understand your topology network design here, and when you are going to assign the direct forwarding, and when we're going to using the carrier tunnel forwarding mode. Okay, so there's a difference here. Introduction to the RF management. The RF management feature allow WLAN to rapidly adapt to changing wireless environments in the real time by using intelligent methods, including the data collection, analysis, radio frequency resource allocation, and RF resource adjustment. So this is one of the features, radio calibration. The radio calibration function adjusts a radio parameter of APs connect to the AC to optimize the radio performance, because we know when there are too many AP deployed at the same floor, same building, so and we're going to maximum the coverage by the AP. So for this kind of the configuration, it will cause a lot of interference. Right. So right here, what is the calibration? Now we have 3 AP. As showing, you notice the AP number 1, AP number 2. This is the BSA, the coverage area. When you try to compare with the AP number 3 BSA, the AP number 3 have wide coverage compared with AP1 and AP2. So now, I'm going to add a new AP into this topology, AP number 4. And I already enabled the radio calibration on my controller. So all the AP will try to scan the surrounding. So they notice they have another party joined to the network, and they have another coverage on this area. So the AP number 3 will try to smaller its own coverage distance, okay, to reduce the interference. So you notice right now, compare the previous and the after, the AP3 have less coverage, okay, and this is the overlapping area. When AP number 4 go offline, don't worry, when AP4 go offline, they actually still exist here, but they just go offline already. Now the AP3, you're going to extend its own coverage area to cover some of the blind spot on the area AP number 4. Okay, this is a radio calibration. They will automatically adjust the coverage. The load balancing. WLAN load balancing ensures the sufficient transmission rate and bandwidth for each SDA by evenly distributing traffic of SDA among AP. So the load balancing is only happening on the overlapping area. Okay, so the load balancing will be never happen in the same BSA. So you need to know the BSA, the coverage. So this is my AP. I have my on coverage. And then the AP number 2 also have its own coverage area. So the load balancing is only applied to this overlapping area. Okay, only the PC connected in this area, the high chance can support the load balancing. So based on the traffic. So when the AP1 is already have too many SDAs connected, so you're going to load balance the user here to the AP number 2. Okay, so this one is based on the configuration that we done. And the next one, the band steering. So the band steering, how to enable that will be very simple. So if you're using the web configuration, so you just have to go to the configuration setup there, choose band steering, and then tick. Okay, then you're already enabled. So the function of the band steering, you're going to force all the SDA can support the 5 GHz to connect to the 5 GHz frequency band. Okay, to save the bandwidth on the 2.4. When the 2.4 is too heavy, too many users connected to the 2.4 already. So for some PC can using 5 GHz, they will load balancing them to the 5 GHz. Then the next one is the WLAN WDS. So connected 2 or more wire or wireless LAN wirelessly to establish a large network. Okay, so this one on the previous one also they mentioned. So for the WDS, we can have the point-to-point, point-to-multi-point, or using the repeated mode. Okay, so this one can using for those kind of scenario when they don't want to deploy too many the LAN cable connections. So to prevent the single link fail, or maybe one of the middle AP fail problems, we can try to using the mesh network connection. So they're using the MPP and also the mesh point and the MAP, the mesh access point, to form the mesh connections. Okay, you have the redundant right here. So other features, besides presenting the feature, Huawei WLAN products support the following basic feature. The first one, SDA blacklist and the wireless management and the user isolation. So we can base on the MAC address or the IP address and blacklist the SDA. For the user isolation, yes, we can enable that also. You can base on the SSID. So for those who connected to the SSID, I will not allow them to form the connections. For the security feature, such as access security policy management, okay, we also can perform some of the ACL isolating. QoS, including the radio and the VIP QoS policy management. And the last one will be Turbulent Positioning. Then the next one, the key feature of Huawei WLAN product. The technology for improving WLAN reliability. So we have the host standby backup, Dueling HSP, or the VRPSSP. Okay, the HSP stands for the host standby. Dueling backup. And the last one is N+1 backup. So to start from the first one, the host standby backup, HSP. The AC HSP mechanism ensures that services are smoothly switched to the backup device when the master device fails. So the solution provides the 2 backup modes based on the different networking. So the first one, they have the master and backup, and the load balancing mode. So let's look at the first one, the master and the backup mode. So what's so different between these compared with another? So right now, my AC number 1 is the master. AC number 2 is a backup. So all the traffic and the AP will only associate and form the carrier tunnel with the master. So in all time, most of the time, the controller number 2 is just a standby device. It will not going to perform any the service configuration delivered to the AP. Okay, it's just a backup. And the blue color link here is running the HSP. So when the master is failed, okay, this is already down. So all the AP will going to connect to the backup AP. Okay, AC number 2. Okay, this is the backup. Then the next one, the load balancing. The load balancing mode can able to split the traffic, like AP number 1 will going to connect to the AC number 1. AP number 2 will connect and form the cable tunnel with the AC number 2. So with this code deployment, they have the load balancing. And you don't need to worry, the AC number 2 is just put there as a standby and become like underutilized. So this is something we don't want to see. You want to make 2 AC have the performance. So we can using the load balancing here. So AP managed by AC number 1, AP2 managed by AC number 2. And don't worry about the controller fail problems, because when one of the controller fail, the other AP will still load balance and connect to another controller. Okay, so AP will going to form the cable tunnel with the AC number 2 automatically when the device fails. Then the next one, the VRPSSP. Currently, the AC use one management VRP group to maintain the master backup status on the entire system and do not support load balancing. When we're using the VRP, they don't support the load balancing. So VRP-based HSP has the following characteristic. The uplink backup each other, and the VRP group can track status of the uplink. The status of an AC may be different from its downlink status. So when we perform the VRP configuration, please take note. So we have to do some the tracing to the uplink. Okay, so when the uplink also faulty, you will always notice the downlink also at the same time. Okay, they're going to shut down the downlink to swap the AP connect to another good condition control. Multiple downlink, including the fixed network and the wireless network link. So when we have a multiple downlink, so that means they right now have the redundant already. All the switches and the controller is connected, and it's like the ring. Okay, it's like the ring topology. So try to using the spanning tree, multiple spanning tree protocol to prevent the loop. Okay, we have to enable that because some of the device, the controller also is part of the switch also. Okay, consider it's a switch. So they also can running the VLAN, and high chance if we didn't enable the STP, they might cause the broadcast dump. So it's recommended when you have the redundant network, try to ensure you enable the MSTP. When the MSTP status is changed, the MAC and rest ARP table of the downlink are automatically clear. Besides user entry backup, the cable tunnel and AP entry need to be backup also. The next one, the Dueling HSP. Dueling HSP have the following feature. Receive and send only the backup service data. Okay, this is a function of the HSP. So you will notice previously, from the picture there, you see they have one light blue color link. So the link is actually used to running the HSP only. So they just exchange the backup service information. So the HSP is support the loop balancing. The Dueling HSP support data forwarding across a layer 3, and therefore support 2 AC using the routing protocol. Next, the Dueling backup. Networking for Dueling backup. AC1, AC2. So they have the redundant network connect. So they have a dual uplink network. In the AC plus Fit AP network architecture, the AC manage and control WLAN services for wireless user in centralized manner. One AC usually control 100 of AP and over 10,000 STA. So when a fault occurs on the controller of the or the link between the controller and the AP is failed, so the service of all the user connected to the AC will be interrupted. So this is the main problem here, because previously all my information is managed by the controller, my master controller. Okay, this is the information stored over there. So when the link here is failed already, it will interrupt our current access user services. So if Dueling backup is enabled, the standby AC control the WLAN service for wireless user. When the fault occurs on the active AC, or the link between the AC and the AP fail, so this will reduce the service interruption time. So this is a process for the Dueling establishing. So starting, how they actually form the connection. So I have two AC right here. Left and right is the AC. At the middle here is the AP, access point. So this access point, we're going to send the broadcast. Okay, try to discover the controller. Then the controller is going to respond. This discover response, they deliver with the priority. Okay, same to the AC right here, AC number 2. It will also send it. So this priority inside the controller is the smaller the priority is the highest the preferred. So now the AP compared with these two. AC number 1, priority 1. AC number 2, priority number 2. So after compare, the AP here, you're going to choose the first controller. Okay, because this is priority number 1. They have a highest preferred than the AC number 2. So AP, you're going to form carrier tunnel with the first AC. Okay, so this one tunnel is already formed. So the AP here will keep continue sending the discovery request to the standby AC. Okay, active standby switch over. So this is my active carrier tunnel. The AP will periodically send the echo detection. Okay, it's like those of the ICMP packet. It keeps sending to the controller there to make sure the link is still established. When the link or maybe the controller never reply to the AP, so the AP will know there's some problem happening on the carrier tunnel. So it will going to build a new tunnel connect to the standby controller, and the standby controller will become the active AC right now. And no need to worry if the active AC come back online, because it will be able to detect it. Because when the AC come back online, the AP will periodically send the discovery request. So when the AC here respond, AP will know. So right now the AC is back online. I need to form back the carrier tunnel with my active AC. Okay, and this one also must make sure we enable the restore function on our controller. If it doesn't enable that, so the AP will never form back the carrier tunnel with our active AC. Dueling backup networking. This topology is showing the inline networking mode, because the traffic all have to connect back to the controller, and this controller have an uplink. Okay, they have a downlink and the uplink, so we'll call as an inline networking. And this is the bypass networking. So the Dueling backup can use as an inline networking mode and also the backup networking, like this. Summary. Basic feature of Huawei WLAN product and the key feature of the Huawei WLAN product.